Hey guys, this is the next lesson 6.3 called Coterminal Angles. So we're learning more about angles. My second attempt at this video, the first one I had to stop and delete, so hopefully this one goes on without a hitch. Okay, so what are coterminal angles? First of all, do not confuse them with reference angles. They are two completely different things. Unfortunately, in the reference angle lesson, we used theta prime to represent reference angle. Here, theta prime is going to represent coterminal angles. So that theta prime is very dependent on context. If the context is reference angles, then it's theta prime is your reference. Now the context has shifted to what we're calling coterminal angles. Theta prime will represent the coterminal. So let's talk about what they are. I'm going to use an example here. The example is best explained with drawing. Actually, when you do your work, you do not have to draw any pictures. It'll go actually pretty quick and easy. But anyway, if we draw an angle on the XY axis, of course, the vertex is at the origin. The initial side is on the positive X axis. The terminal side, you could either rotate counterclockwise, like this one for a positive angle, or clockwise for a negative angle, but that other side is called the terminal side. If I draw a second angle on the same XY axis, its vertex has to be at the origin, and its initial side always has to be at the positive X axis. So all angles have the same initial side. But if I were to draw, let's say, a negative 20-degree angle, its terminal side, of course, will be down here somewhere. Very slim angle, something kind of like that, negative 20 degrees. So a coterminal angle would be a second angle that not only has the same initial side, but it also has the same terminal side as the given angle. So I'm going to draw a second angle that has the terminal side in the same place as 100 degrees. You might say, well, you just draw 100 degrees again, and now they're coterminal. Well, that's true, but that's kind of a trivial example. A more robust example might be something kind of like this angle right here. So this is a negative angle, same initial side, same terminal side, but it is not 100 degrees. How big is that angle? Well, you could find that angle by subtracting 100 from 360. So 360 minus 100. Well, actually, because it's a negative, I get 260 here, but it will be a negative 260 degree angle. So negative 260 degrees is coterminal with 100 degrees. Now I'm going to erase this little scratch work because there's another coterminal angle. Let me go to another color. I could draw an angle that starts here and is positive and rotates around a complete 360 and ends there. So this blue angle is also coterminal with 100 degrees. How big is the blue angle? Well, the blue angle is going to be that 100 degrees plus 360 for a total of 460 degrees. So it turns out that 100 degrees is coterminal with negative 260, and it's coterminal with positive 460. So does that mean every angle has two coterminal angles? No, it actually means every angle has infinitely many coterminal angles. This is going to look goofy, but I could, let's pick a color I haven't used yet. How about bright pink? I could start here and rotate a whole bunch of times and then stop right there. And now that bright pink angle is coterminal with 100. What is it? I didn't really count, but it's going to be 100 plus 360 plus 360 plus 360 plus, as many 360s as it takes to end up at that spot. So it turns out that you can find coterminal angles with any given angle by adding 360 or subtracting 360 or adding multiple 360s or subtracting multiple 360s, right? We could go this direction, half a dozen times, and then stop there. And that's a coterminal angle. Now look at that. That's what I call math notes. Awesome. But do you get the idea? Any given angle has infinitely many coterminal angles. It just depends on what direction you go and how many times you wrap around the XY axis. In general, if you want to keep it simple, if you want to find two coterminal angles, add and then subtract 360 from your given angle. If it's in radians, you're going to add or subtract 2 pi radians. And that's basically it. So yeah, technically any angle has infinitely many coterminals. There is a formula for that. So if you're given the angle theta and you want to find a coterminal theta prime, then you can use this formula. Theta prime equals theta, the original angle, plus 360 times n. So if you multiply if you make n a 1, 360 times 1 is just 360, so it's theta plus 360. If you made n a negative 1 times negative 1, so that's supposed to be a dot for times, then that's negative 360, that's theta minus 360. If n was a 2, 2 times 360 is 720, right? If you skateboard or do any sort of like extreme sports where they spin, 720 is 2 rotations. So take the original angle plus 720, right? 2 times 360. Then there's another coterminal. Instead of making that a 2, you could make it a 25. 360 times 25, that's like 25 rotations and then stop on theta. So this formula, depending whether you plug in a positive number or a negative number, can give you infinitely many coterminal angles. This formula is exactly the same, except it's in radians, 2 pi. But if you were to plug in like a 5 times 2 pi is 10 pi, that's 5 rotations. So if you're graphing, it'd be 5 complete rotations, and then you end up on whatever theta is. So if you want to make it complicated, you use one of these 2 formulas, and then you plug in positive numbers or negative numbers, and that gives you coterminal angles. You want to keep it simple, which we're going to do. You're going to add or subtract 360, or add or subtract 2 pi, and then that'll be good enough. We're not going to find infinitely many coterminal angles. So what are the directions? Find a positive and a negative coterminal angle for each given angle, starting with 30 degrees. So if we want to find a positive coterminal angle, we're going to take 30 and add 360 and get 390. And I'll put the degree symbol on there. Supposed to put the degree symbol everywhere. I forget, but I tend to forget. So there's a positive coterminal. A negative coterminal is going to be 30 degrees minus 360 degrees. 30 minus 360 is negative 330 degrees. And there we have it. A positive and a negative coterminal. Let me check number 3 and see if that's right. And there it is. Now, are those the only right answers? No. Instead of adding or subtracting 360, I could have added 720 and subtracted 360. Or I could have subtracted 720, right? In fact, you can find multiple versions of these answers. I've had students try to really push my buttons in the past, and they'd take 30 degrees plus 36,000. Well, it's not really pushing my buttons. I mean, that's pretty simple, but that's, 100 rotations, 360 times 100. But that is still a coterminal angle. But without an answer key for students to check themselves, you're forcing the teacher to think this through and figure out, did you actually do it right or not? So I'm going to suggest that you only add or subtract 360. If you want to do more than that, it's up to you. All right, number 4. So to find a positive coterminal, negative 315 plus 360, that works out to be, what, 45 degrees. To find a negative, 315 minus 360, what is that, 576. Negative, don't have room for my negative. Negative 675 degrees. All right, 45, negative 675, right there. And by now, hopefully you see, hey, this is pretty easy. This is not going to be something that really stresses you out or causes you heartache. Oh, sorry, not 330. So, all right, my brain is stuck. So 300 degrees plus 360, that's going to be a positive coterminal, 660 degrees. 300 degrees minus 360 is negative 60 degrees. And look, I'm doing mental math. If you need to plug this into a calculator, so be it. Knock yourself out. It's not going to hurt anything. 60 and negative 60. There we go. The next one, negative 128. So I need to do negative 128 plus 360, negative 128 minus 360. And wow, I am about brain dead at this point, fried. This is the 6th lesson I've taught between pre-calculus and algebra 2. And so I'm not going to trust myself to do this in my head. So here we go, 232 degrees and then just go ahead and change that to, well, minus negative 488 degrees. Come on, cooperate. Seriously, I'm so frazzled I can barely think straight. Having to start this lesson once and then stop in the middle and delete it and start over really upset my mental apple cart. Okay, so there's a whole bunch of examples in degrees, and hopefully you see how easy it could be. Now, can this be trickier? Yeah, let me make up problem 8.5, right? So between number 8 and number 9. You could be given, let's say, a negative 700 degree angle, and you're asked to find a positive and a negative. Well, if you take negative 700 degrees and add 360 to it, oh, here I go, and I got rid of the calculator. So what is that? If I borrow 10 minus 6 is 4. That's negative 340. That adding gave me a negative answer. If I subtract negative 700 minus 360, I'm going to get an even more negative angle, right? Or is that 1060? But the directions say to find one positive and one negative, so I can't do that. Adding gave me a negative. Why? Why did it do that? Well, because this was so far negative in the first place. It was like all the way around the graph and more, you know, one of those snail shell type angles. So what I need to do now is take the previous answer and add 360 again and get 20 degrees. So sometimes the angle is so far negative you have to add 360 a couple of times to get a positive answer. Or alternatively, maybe that was positive 700 degrees. Then I'd have to subtract 360. That answer would still be positive, so I'd have to subtract 360 again. So yeah, these problems can be a little trickier, a little more complicated, but you don't have to worry about that today. What you do have to worry about, though, the rest of this paper, is that we are now in radians. Now, one technique would be to multiply this by 180 over pi, change this to degrees. Once you have an answer in degrees, you can add your 360 and subtract your 360. But then you have to convert it back to radians. So you're doing a conversion, you're adding and subtracting 360, and then you're doing two conversions, and that can be a lot of work. It will work, and you can do it that way. However, I just want to throw out there the idea of adding or subtracting 2 pi. Okay, so we do have a fraction here. We've got pi, which is a variable, or I'm sorry, it's a constant, but it's a letter, a Greek letter, which looks like a variable. You feel like this could be complicated, but hopefully once I explain it, you'll see that it's not complicated. So to add or subtract a fraction, of course, you need a common denominator. 1 is the easiest denominator to make common. You just look at the other one, it's a 12, so I'm going to have to multiply this by 12 over 12. So I get 17 pi over 12 plus or minus. I'm just taking a shortcut there. We're eventually going to add and then we're going to subtract. So 2 pi times 12 is 24 pi over 2. Now we're going to get two answers. When I add 17 plus 24, that's 30, that's 41. 17 plus 24 is 41 pi over 12. Forgot my 1 down there, over 12. And then we have to subtract 17 minus 24. 17 minus 24 is going to be negative 7 pi over 12. And there are my two answers. Now, how did I say that this was going to be easy? So I'm going to explain how you can do this and kind of just skip that step. All right, so let me start over. 17 pi over 12. I'm going to separate that out and make my pi look more like it should. So here's what you do. Okay, whatever the denominator is, double it. Why would you double it? Because 2 pi. There's always a 2 in the situation, in this scenario. So double it. 17 doubled is what? I'm sorry, 17. 12 doubled is what? 24. So all you really have to do is take this number here and add or subtract double whatever the denominator is. 17 plus 24 is 41, and 17 minus 24 is negative 7. Oops, already had my fraction bar. And you get the two answers. If that didn't make sense here, I'll do it on number 12. And coincidentally, the denominator is 12, but that's okay. Double 12, what do you get? 24. So we're going to add and subtract 24 with 7. I'm sorry, with negative 7. Okay, that's important. That negative goes with the 7. So negative 7 plus 24, negative 7 plus 24 is 17. So you make that 17 pi over 12. And then negative 7 minus 24, negative 7 minus 24 is negative 31 pi over 12. So number 12 should have those two answers. Let me check. Oh, I never did check 10. Oh, yep, there they are. And number 12, 17 pi over 4 and negative 31. I'm sorry, 17 pi over 12 and negative 31 pi over 12. And there they are. All right, if that wasn't clear, let me go down here again. So pi over 3, that's the same thing as 1 pi over 3. You know there's a 1 there. So double the denominator, that'd be 6. We're going to add or subtract 6 from 1. 1 plus 6 is 7, so that's 7 pi over 3. And 1 minus 6 is negative 5, so that's negative 5 pi over 3. And there are my two answers. Number 14, there it is. You see, technically what you're supposed to do, again, pi over 3 plus 2 pi over 1, multiply by 3 over 3, find the common denominator, add it and subtract it. 1 pi plus 6 pi is 7. 1 minus 6 is negative 5. You know, but you just don't have to do all the work. One more time. So what's the denominator? 4. Double it, 8. We're going to add or subtract 8 with negative 11. So negative 11 plus 8 is negative 3. So that's negative 3 pi over 4. And negative 11 minus 8 is negative 19. Negative 19 pi over 4. All right, hold on, hold the phone. So we got a problem here, right? These are both negative. But we want one of them to be positive. So, what I said before wasn't going to happen because it's too complicated. Yeah, it looks like it's happening. So the answer we got by subtracting is just unnecessary. What we need to do is add 8 instead of add and subtract 8. We add 8, we get negative 3 pi over 4. Now we're going to add 8 again. Negative 3 plus 8 is positive 5 pi over 4. And so these would be our two answers. So 16 was a little tricky. I don't think your number 15 is going to be like that at all. You should be fine on number 15. But my number 16 turned out to be a little trickier than I planned. Hopefully it didn't throw you off too much. Okay, so let's summarize real quick. The drawing is clear. I mean, it's plain as day, right? No, okay, I really messed that up. Let me get rid of some of this. So if angles terminate at the same line, at the same terminal side, they are called coterminal. Generally, if you want to find two coterminal angles, add 360 and subtract 360. You could add 360 multiple times, over and over. You could add 720, subtract 720, but it gets the job done. If you're in radians, you want to add and subtract 2 pi. One more time, just in case it wasn't clear, how can you make that work easy? How can you make that work easy? Sorry, get stuck on a thought. Double the denominator, 8. Add it and subtract it to the numerator. 1 plus 8 is 9. 1 minus 8 is negative 7. I've pretty much done number 13 for you. Okay, I'm going to stop right there. Good luck on these. If you have any issues or any trouble at all, please contact me. Let me know. I'm looking through here. Actually, it looks like number 11 is going to be kind of bad, sort of like my number 16 was. And I didn't, you know what? I didn't mean to do that to you, so I'm going to go ahead and do number 11 right now real quick, just to be fair. If you think you can do it, stop the video and get to work. Otherwise, here we go. 6 times 2 is 12, so you would think I would add 12 and subtract 12. Well, negative 23, remember that negative sign goes with the 23. Negative 23 plus 12 is negative 11. So that's negative 11 pi over 6. If I now minus 12 to get my second angle, it's also going to be negative. And I don't want two negative answers. So instead of adding 12 and subtracting 12, I'm going to add 12, which is what I just did. So that is one answer. But then I'm going to add 12 again. What's negative 11 plus 12? Negative 11 plus 12 is positive 1 pi over 6, or just pi over 6. So number 11, hopefully I did that right, and there they are. So yeah, I did not intend 11 to be tricky. There you go, one of your homework problems done for you. All right, I'm going to stop here. I feel like I'm just rambling on and on. Again, contact me if you have any questions.